Welcome to the CAD Office Training Guide series for F.Connect. I'm John Mark Palacios, CAD Applications Engineer. In this session, I'll be going through the F.Connect Roadway Design 3D Modeling Guide. In this course, we will learn the Bentley Open Roads Designer Connect Edition tools for design and 3D modeling within the F.Connect workspace. In this series of videos, I will take you step by step through each exercise from the guide. In this session, we're going over Chapter 6, Earthwork, and Chapter 7, Visualization. So for earthwork, we're going to first discuss the methodology of the difference between surface to surface versus average into area earthwork calculations and how this new method works, in case you're not familiar with it. Then we're going to go into the process of creating cut and fill volumes in Open Roads Designer and analyzing that volume. Further, also option to do a surface to surface directly from two different surfaces once you've created the surface, which we did in the previous chapters in 3D deliverables. Then we're going to go into visualization. We'll show you how you can visualize the existing ground with more than just DTM. You can actually pull in aerials. We'll do a 3D drive-through animation, and we'll also show you how to export to LumenRT, which opens up a whole lot of options. You can view it in 3D with the textures on a screen, or you can even put it on Oculus Rift or some other virtual reality headset and view it there and literally walk through your project as if you were doing a site visit for your proposed project and check to see what issues you have with your model that need fixed. Alright, so let's look first at the different earthwork calculation methods. So the old way, you're probably familiar with this, you probably learned it in engineering school or somewhere along the way. Average into area method. Basically, you take intervals, 50 foot, 100 foot, and figure out the area of the cross section for cut and fill at each of that interval, and on both ends, and then you just multiply it by the length of the interval and you get your volume, and then you keep doing that repetitive fashion along the length of the project to get your entire volume, sum it up. So by contrast, the surface comparison method, basically instead of doing those intervals, you're taking two surfaces. You have your proposed finished grade. Well, actually there's three surfaces. Let me just clarify. In the 3D deliverables, we created a proposed finished grade, we created a proposed bottom surface, and we created an existing surface. The proposed finished grade includes pavement, so we're not going to really concern ourselves with it for earthwork purposes. That's definitely the one they want to use if they're using automated machine guidance for doing pavers. Then you probably need to build to that. But if you're just doing earthwork, you're doing grading, if you want to use automated machine guidance for that, you're going to need to look at that bottom surface. And if we're doing earthwork calculations, again, that bottom surface is the important one. Now, that's the reason we create it. So basically, on the surface comparison, you take that bottom surface and the existing ground, put the two together, and just look at the difference between the two. And that 3D volume between those two surfaces is your earthwork, and it's a lot more accurate than the average into area method. Now the existing ground, of course, you should be getting from survey, but you're going to be creating the proposed finished grade and bottom surfaces. There's a few similarities I just want to point out. For the average into area method, you still need the existing ground, the digital terrain models, and you still need a proposed surface quarter model. That's kind of the way we did it in SS10 and in SS4. In the surface comparison method, same thing. You're going to use the DTMs and you're going to use the quarter models. We're just going to take a different approach to what we do with that information. The average into area, you're just building cross sections that show the existing ground, that show the quarter model. The surface comparison method, we're literally just looking at the 3D, not really concerned with cross sections. So a little bit more on how the calculation works. I mean, here's an illustration. Already kind of elaborated on the average end area. You have the intervals. There's kind of an illustration there that may help a little bit. How it works if you're not as familiar with how it works, but it's just, if you want to get more accurate, the main thing with that is you have to decrease the interval, and 100 foot is really the max interval you could have for cross sections. And you got to remember too, it's an approximate, because you're essentially taking an average between that interval. I mean, you could have some weird things going on, and you lose a lot of accuracy. For example, you could have an asymmetrical roadway. Maybe you're just doing adding a lane on one side or something like that, and then you go around a curve, and that you're gonna get really far off because it's no longer kind of symmetrical prisms going about the center line. It's kind of lopsided, and the curve opens up on one side, and so the interval is, it's like 105 feet on this side and 95 on the other side, and it's throwing off, or the curve might even be tighter than that. So there's a few examples like that. You start to lose accuracy with different configurations, different project specific issues. The surface comparison method, the accuracy is only dependent on how accurate your survey is. How many points did they take, how closely were they spaced, and well, presumably they took them accurately, but really how tight it is, and it's dependent on the interval settings in the corridor. And that's what we set in chapter 2. We set the corridor interval. We discussed, this CAD manual table that talks about the interval spacing. That's important primarily for earthwork, but other quantities as well. So the tighter that spacing is, the more accurate your calculations are going to be, but you're still going to be limited by your survey accuracy. So then basically what it does is a little diagram here. So you have triangles on both top surface, or well, the two surfaces, it's the bottom surface and the existing ground, and it's creating a prism basically between every triangle on both surfaces. So it's gonna basically create a whole bunch of little prisms. This is computationally intensive, and of course with the computing power we have, it's fairly trivial, and it doesn't take a long time these days. Whereas the average end area was something that originally could have been done, I don't know the history of it when it was started to use, but it's certainly something you can do it by hand completely without even using a computer. You can just punch it into your calculator if you want, and some people may do that to check the volumes, even scale it off plans and write down the numbers and sum them up. You can do it. It's certainly easier if you have fewer cross sections, but you're always going to have a lot of triangles on the surface comparison method. So pretty much need the software to do that for you. Which leads into the next question: how would you check those numbers? So if just letting the software do it for you, reviewers and engineers want to verify. So how are you going to verify that? Average end area method, the ways we did it before is you can of course verify it manually, scale it off, or you can create a multi-line gen file. Those were the two primary methods on the average end area. You could do verifications. You could still verify by creating a surfaces and verifying it by doing surface to surface comparison, and just as a different method to do it. For surface, if you did a surface to surface comparison, which is pretty much the only way, well, I should say it's the primary way of doing earthwork volumes in OpenRoads Designer. The best way to verify it is going to be to export the surfaces that we created in 3D deliverables. You got your finished grade, the bottom surface, and the existing ground. Export all of those, and then import. If you want to verify it yourself, if you're a designer wanting to check that, just open it up in Trimble, or whatever similar software that can open those LandXML surface files and run calculations, because this is what contractors would be using. So if you open it up in there and actually run earthwork calculations there, and it's an independent, it's presumably a different algorithm. It's the same method, I believe, but presumably they have different programming underlying it, so it's completely independent from OpenROADS Designer. So it's an independent check. It's a safe bet. What I would say, I should point out in the average engineering method, the gen files, even in SS10, we're not actually doing gen files anymore. The provision of 3D deliverables, that's how we're doing it, and that's how we're verifying it, even if we're doing average engineering method. So there's, like I said, multiple ways to verify that. One other thing to point out now, specifications are kind of in the process, probably going to be revised as part of the efforts with next gen plans, and they may have been revised by the time you watch this and do this training, but currently, as of 2021, early 2021, the way the specs are worded does allow, even though it's primarily focused on average end area, it says unless the engineer determines that another method of calculation will provide a more accurate result. So it still allows that leeway to do the surface to surface comparison method, because that, you would say, it is a more accurate result. It's totally dependent on that corridor interval. Going back to this picture again here, these are very small triangles. These might be 1 foot. These might be a couple inches. They're pretty small. It depends again on the bottom is this triangle size is determined by your how close the points are on the 10, and the triangle size on the top is determined on how your corridor interval is set. And if you want to make it more accurate, basically just increase the interval on areas where there's more complexity. Areas like radius returns, intersections, curb ramps, median noses, anything where there's tight radii happening. That's where you want intervals to be tighter, and it may be an interval, or it might be a stroking definition if it's a linear template, or if it's just a surface template and lines that you built off of. You change the stroking definition, which we did in chapter 4, will affect that. And the other thing with the interval settings, if you have that densify curve options, it'll make it slightly tighter when you get on a curve, even on the main line of a corridor, which also helps to become a little more accurate on the curves. And where you don't need as much accuracy is typically on the straight sections, where there's not a lot of change happening in the corridor. I mean, there could be change happening in the earthwork at any point, but certainly if there's change happening in the actual corridor, you want to account for that. And of course, if you add key stations anywhere, that's basically another interval. So anywhere you can focus in, hey, throw a key station down, clean up those glitches, and it'll provide a better picture and more accurate quantities for earthwork and your other quantities as well that we're pulling off of here, but we're mostly concerned with earthwork. So with that, let's go on to the exercises. Alright, we're going to start with exercise 6.1, and I already have OpenROADS open here. We're going to open up the MODL RD mainline 61. So the one thing about cut and fill volumes, so go to your 22049555201_CE, and we created a master file, but that's not the one we want. I don't see it in my list, so I'm going to browse to it. There's it, MODL RD mainline 61. So we created a master file, but we can't use it to calculate earthwork. And the reason for that is simply because earthwork has to be quantified by alignment, and we can only create separate we have to have separate files in order to create separate cut and fill shapes, because it creates cut and fill shapes for the whole file, every model that's attached. So the way we set it up and some of the steps that we took through the design was all kind of geared towards this fact that we cannot even have the other alignment for US98 attached to this file. And so we're going to run it for the 61. So we pick one file to run it in. It could be, honestly, it could be the mainline or the detail. It doesn't really matter. We're going to do it in the mainline file. And I'll actually take that back. It does matter. See, the problem is the detail 61, we have the US98 model referenced in. And the US98 model, if you so much as reference it in, and we have to have referenced in because we're using it for building profiles and such. So if you so much as reference it in, even if you turn the display off, it's still going to calculate it when you're doing cut and fill volumes. So by referencing in from this file, we can just reference the detail, the ImmoDeal RD detail 61 file. So we get the intersection detail in here plus the in conditions. So all of the 61 model will be in this file without having the US98 in there. So we're just going to go to home and attach references. Make sure your 2D view is active. So I'll go to attach and I'll go to the ImmoDeal RD detail 61.dgn. Click open. I'm just attaching the default model. Make sure you don't have your live nesting depth more than 0, because you don't want to pull in any. You don't want to pull in the US98. So you should see this, and only this. Just got the in conditions and got the intersection. So that's good. That's ready to go. There. You have the existing ground. Those are the main features that you need. You get your existing and your proposed. So all that's attached to this file. That's the important part. So we can go ahead and create cut and fill volumes. So I'm going to close the reference dialog. Let's go to the next step on page 6-3. So we'll come over to the Home tab in the ribbon. We go over to the Model Analysis and Reporting section, right here, kind of about the middle. And we're going to Civil Analysis and click the drop down on that because there's a lot of tools under that. And we're going down to Create Cut Fill Volumes. About midway, bottom half of the section, Create Cut Fill Volumes. So just select that. The default options should be okay. There's not really a lot of options on this. You got cut fill volumes. You pick a feature definition. The feature definitions are the only two under volumes that we have defined. Volumes cut, volumes fill. There are some options to compute unsuitable material, and we're not going to go over that in this training guide, but it is possible to have an unsuitable feature definition as well, and classifications. So for this one we just have cut and fill, so I'm just going to accept through these options and it'll create the volumes. Data point accept. Now it's going to be on a construction class, so you're not going to see it by default, I think, because we probably have constructions turned off in the 3D view. The only place you're going to see it is in 3D view. So I'm going to come over here and turn on constructions, or use F7 if you want the keyboard shortcut. And now I see these red and blue triangles. So that's my cut fill shapes. You know, it's basically a surface that it created. And you can also see them in the cross section view. So you can here's my cut volume. See if I can find a cross section where there's a little bit of fill. Oh, there's a little bit of fill right here. Well, no, this piece right there, that little triangle got a little wedge of fill. So it's there. It's red and blue. Those are your two colors that you need to be looking for. Now I will show one thing real quick. If you look on your feature definitions, so if you go under Open Road Standards, and I'm just going to show you on the mesh feature definitions. Here's under volumes. Here's the cut and fill ones that we created. And item types, when we get to quantities, are going to be attached there. You can also edit if you want to have cut factors, but I don't think we usually use those. But the other thing I want to point out on these other meshes, if you say, let's pick payment for example, there's a volume option right here under the mesh. This is what's used to determine, is it existing, is it design, is it subgrade, is it unsuitable material. So you can change the classification. This was called classification if you did the earthwork calculations in SS10. That's what it would have been referred to as. So it is important for your existing features to be in here as well. I think this one yeah, this one we don't have the existing features attached, so it's not actually going to be 100% accurate when we get to this end of it, unless they're attached and just not shown. Let me take a look. Nope, they're not attached. So if you want to include them, the existing feature definitions, and I'll show you here under libraries. If we go in the same place under mesh, under XS. So let's take, there's a driveway EX. You can see the volume option is set to existing. On this one, I would definitely make sure you have the latest version of the F.Connect software, and of course the matching version of the OpenRes Designer Connect, because we have updated many of these as we've developed the quantities workflow. So these feature definitions may not have the correct setting if you're using an older version. They may not have the volume options, or if you just don't have the feature definitions set correctly in your files, then you're going to have issues with the calculations not working correctly. So since I did this without that being in there, I'm just going to go ahead. This will be handy because I can show you how to delete it. It's not very straightforward. So like I said, it doesn't show up anywhere but the 3D model. I can see it under standards, but you know, most of the civil geometry shows up under OpenRoads model. So if you've used this at all, you kind of get used to, okay, you know, I can go to corridors under here, and my reference model should show my terrain models here, but there's nothing else. There's no volumes here, so I can't just go in here and delete it. So if you need to delete it and redo it, you just need to go into the 3D view, the only place you can see it. Just grab the triangles, just select it, and delete. Should be able to get the pop up. If I can get it to come up, I can't get it to come up. So I'm going to right click over here in properties and do delete. So that got rid of, and remember there's two shapes. There's two shapes. They're even if they're disconnected, but you got one for the cut, one for the fill. So we got to find that fill. Okay, here it is. Look for the blue. So I'm going to select that. I'll just go over here into LT fill. I'm sorry. Volumes fill. I got the wrong thing. First time I selected it, was the mesh. If it helps, sometimes you could turn off all the other meshes. If you come in here under OpenRes standards, just uncheck the XS, and that'll leave just the volumes there. That's only going to affect this file, but it makes it easier to select it, most likely. So I just hit the backspace key on the keyboard. That also gets rid of it. I'm going to turn this cross sections back on, the cross section meshes. Alright, so we need to attach the existing features. So I'm make sure my 2D view is active. Go to attach reference. And I'm going to attach my model RD existing features 01. For earthwork, we shouldn't need drainage or utilities, so I'll just do existing features and leave it at that. Now it should be showing in the 3D as well. but it certainly might be that I have the levels turned off. So let me just check that level display on the existing features. Go ahead and turn everything on. Like I said, it doesn't matter. It's still going to calculate whether it's on or off. I can turn the display off on this altogether, and it's still going to get calculated in there. So this will just ensure we have the correct volume, taking into account existing features in this area. As obviously this pavement shouldn't get counted as earthwork, right? And neither should this pavement. Not that we're touching that. Well, we are touching it in this little piece. So, okay, so existing features are attached there. So let's just rerun that same command. Go here into civil analysis. Since I ran already, I'm just going to click the button. Going to accept all the options. Let it process. Alright, so there it is. Now you should see the volume taking into account. There you go. I get the right handle here so that you can see the cut volume. It goes under that existing pavement. So that's good. That's why we need the existing features to count. Get a much more accurate picture that way. And this is down here at the end where, yeah, it overlaps. Alright, so that's ready on this file. You're ready to, done with the modeling part. This overlaps a little bit with quantities. We're not getting into quantities in this file. We're just trying to show you how to do the earthwork volumes, create these volumes so that you can then, run with that once you get to doing quantities. So it'll be ready to go. Alright, so that part's done. We're going to open up the US98 file. At the bottom of page it's the bottom of the same page. Just go to create cut and fill volumes for US98. So we're going to open up US98 file, and we're basically repeating the same steps. And that includes adding the existing features. So let's make sure that's added if it's not already on there. I think I've got some meshes turned off, or maybe levels turned off, and I'll just check in my OpenGrid standards and make sure everything is turned on. Okay, so I don't have my existing features model, so let me go in. My reference is still open, so I'm going to go over in here and attach reference. Make sure your 2D view is active before you do that. Attach them MODLRD existing features 01. Click OK. And I think probably because the settings in that file are all those levels are off, so I'm just going to come in here and turn them on. I'll make this 3D view active and select it and just do all on. Okay, so now I can see it. Make sure that's why I can make sure it's know where it's going to be calculating and taking those into consideration. I'm going to close that reference dialog. Actually, before I close it, just make sure that you do not have the other model referenced in. So I got existing, and yeah, the 3D model of the same file, but I do not have the 61 model. So if that were referenced in, even the display turned off, it's still going to calculate it. So gotta be careful with that. Something to think about when you're doing your model management plans is how can you split it without referencing the other ones. It's tricky, but it's otherwise you're going to be doing a lot of manual effort. So it'll make it easier for when you're coming to do volumes. Alright, so I come to the same place over here, and I'm just going to hit the button again because it's the same tool. Civil analysis, create cut fill volumes. So same, accepting the defaults. Just accept all of those. Data point. Give it a second to calculate. Alright, so it's done calculating. Let me turn on the constructions. And make sure it shows up. There it is. I can see it. It's harder to see because there's a lot going on in this file. Again, this might be where it's handy to turn off the meshes. I can even turn off the template miscellaneous. Get rid of those lines, at the very least. So it's a little easier to see. But again, because this is a resurfacing project, it's kind of, in some places it's flush with the existing. So you got different shades of red, and there's a whole lot going on with that. So it can get a little bit tricky. So that's certainly where it might be useful. Let me just come in here and turn off the cross sections altogether, and that doesn't affect the existing features. So that might be, let's go in here and just turn off the display of my existing features in the 3D view, and okay, now I can see my cut and fill volumes. So I know it calculated, and of course this is resurfacing, so it shouldn't be calculating anything in the middle there. And if all your definitions are set correctly, you got your overbuild, overlay. See volume option here, set to none, because this is not counted in earthwork. The base, yeah, that has a volume option. And your pavement asphalt over the widening section. This is part of the reason we have separate one for the overlay, the overbuild, and the pavement asphalt, so we can get those earthwork calculations done separately. Also, probably so you can do a different pay item easier and just assign it to that whole feature definition. But I think that wraps this part up. We can go to the next exercise, 6.2. So we did the create cut fill volumes, and you're going to use these to do quantities. But there's another tool that could be useful for some analysis. It won't be for doing the summary of quantities or anything like that, but it could be useful for a few things. So for that one, I'll go ahead and turn these back on first. I'm going to open up the the master model file. Let me browse to it since it's not in my list here. MODLRD master 01. And if you remember when we did the 3D deliverables in chapter 5, we created surfaces, and we need those for this exercise. They were not created in this file though. We created the AMG 3DSGN01 and AMG 3DSGNRDEW01. So what we're going to do is reference those two in, just so we can pull in the surfaces and do analysis in this file. It would be potentially possible to do them in those files as well. Maybe you just reference in the existing ground, but this way we can have them both in one file and do analysis between all three different surfaces as we want. So I should have my existing ground, and I think that it's off in the 3D view right now. Should be on the GDTM file. There we go. There it is. Alright, so I can see the boundary at least for it. I've got my models, I've got the earthwork surfaces. We're not really concerned with the earthwork meshes, we're just concerned with the surfaces. Alright, so if your 3D view is active, you want to make sure your 2D view is active first. And step 2 here, we're going to attach the AMG 3DSGN01 and the AMG 3DSGN RDEW01. So the two files that we created in the 3D deliverables chapter, we want to attach them in the 2D view. Now they're 3D files. You might think we'll attach them to the 3D view, but we actually need them attached in the 2D view for this to work. So we're just going to come over here. If your reference is not open, you open it up from here and come over here and select attach reference and navigate to your 3D folder. So we created in this one it's the proposed top surface, and the EW it's the proposed bottom surface. And make sure you select the DGN, not the DWGs on this. So you can attach DWGs, but they may not have the surface that we need. So select those DGNs, and click open. We're going to accept that, and you know, just here instead of default it shows model because this is a 3D file. So just click OK on that. You can accept those settings. You should see these DTM surfaces show up now in your 2D view. And the main thing is, if you may not have had OpenRoads model up here, but I opened this up, I expanded out reference models, and you can see in here the AMG 3DSGN-RD, and there's terrain models. So there's my terrain model for that one, and there's a terrain model here. This DTMPR. Now this isn't the best name, but those names are to keep those in mind, whatever they are in your particular project. That's what we're going to be using. So this is our proposed top in the AMG 3DSGN. So DTMPR is proposed top. AMG 3 surface EW01 is our proposed bottom. So let's go to the same section that we were in the last exercise. Under civil analysis, click the drop down. And we want to go to the option for analyze volume towards the top here. So just select that, and now there's an option for volume method. So if you select that, we want to use terrain model volume. You can terrain model to plane. That's not particularly useful for what we're trying to do here. So just make sure you select that, and then there's going to be drop downs from terrain model to terrain model. So the from is going to be existing ground. So just scroll down here till you find the existing ground. And it's in here twice because we have attached the ServRD, and it's in there, and the GGTM, and it's in there. If you just have it in one source and the ServRD only, then you won't have it doubled up like that, because I really have no way to tell which one is which by selecting it here. I might be able to actually highlight it when it prompts me, and in that case then I could probably select it here. But if you select it from the drop down, then I would go to terrain model. See, now the other problem is I got like 3 DTMPR models here. That's an issue of poor naming. So the only way I'm going to fix that is by fixing the name in the design. Okay, I fixed the name in the other file. You have to go into that file and change it. So if you bring up properties for it, you can change it right here in the feature name, but it's grayed out in this file because it's a reference. So open that file and just go to under terrain models. It'll be under here. You can change it there if you need to. Now I should be able to run that tool and have a differentiation between the two names. So terrain model volume. I'm going to accept that. So it asks me to locate from terrain model, so I'm going to select it here rather than from the menu, so I know I'm getting the right one, the GDTM-RD01 for the from. And then for the to, I could try to select it here. That's certainly one way to do it, and that would alleviate, I guess, the naming issues as well. So you can see it's AMG 3 Service EW01, or I could select it from the drop down. So now it's showing the right one. So we're going to use the EW01 because that's the earthwork. So if we're trying to do earthwork volumes, that's the one we want to use. Now, if we wanted to do, let's say, pavement volumes, for example, Of course, knowing that is actually probably going to include things like sidewalk. You could do from the EW01 to the PR01, and it would give all those volumes. So we're just doing existing ground. So now cut and fill factor of 1. Boundary reset for none. And this checkbox is kind of an optional thing. So if you don't check it, it's going to just show you the results down here. Very hard to see. If you check it, it'll actually give you the option to drop it in, put it in the file somewhere. So I'm going to leave it checked to save result. And then ask me data point to place results. And the results should be in the message center, so I didn't even see them in here, but I'm just going to data point in here somewhere. The other thing I'm looking at is I don't see. Okay, so there it is. After I insert it, it's a little hard to see, but it is there. And these volumes are in your working units, so be aware of that. This is in cubic feet, not cubic yards. You got to do that conversion on your own. You can see it's got the 3, which I think just means it's cubed. But this volume, you know, may seem high, but that's because it's in the working units. And you should be able, this thing should have a handle on it somewhere. I don't know. Not seeing it, but you could always probably use the move tools. It's basically just a text box. You can see it's a text node. So you can do what you need with it. Put it farther away from your design so it doesn't overlap like I did. Alright, we're going to move on down to chapter 7. Just flowing straight in there. So we have the master model already open. So one of the things we want to do, one of the things that comes up often is, how do you clip the existing terrain? If you're trying to do a visualization, it can be challenging. First of all, I'm going to delete this thing that I just added because it's in the way. If I right click here in properties, I should be able to delete it. There we go. So when you export to say Luminar T and some of these other tools, the existing ground, if it's turned on with triangles and everything, it covers up this proposed model. So let me just show you real quick. Go to OpenRoad standards. I'm going to turn off the feature definitions. Oh, I can't turn off feature definitions. Everything's referenced in this file, sorry. I have to go to my level display, turn things off. So if I just select my main line and my US 98, I can turn off the volumes. This needs to be my 3D view. In my 2D view, what I want to turn off is my the ones I just attached. The 3DSGN RD01 and the EW01, so they're not cluttering it up. That looks better. In my 3D view, I want to turn off cut and fill volume, so I come over here to, I'll just do all the model files. If in doubt, that's the easiest solution. Then I'm going to turn off cut_PM and fill_PM, just to turn off those two levels. And I think, well, I also have my 3D attached, so those are showing up. So I'm going to turn off the display of those two. And I think there's a few other triangles that are still showing up. See if I can identify what this is. It looks like the cut fill volumes. Yeah, so the level is earthwork 4_px, so that's the other one I need off. I think I turned off the wrong line. So cut PM or fill PM are just the lines. It's the earthwork 2px and earthwork 4px. There we go. Yeah, you got to remember that PM is always points and px is always meshes. Alright, so this is a little bit cleaner, but if I turn on, if I go in here into my GDTM RD01, and right now the triangles are not showing. But if I were to change the feature definition so that they did show up, then it would be a little bit problematic. Because it would be overlapping. Probably the easiest way, servrd maybe. Turn that on. So you can see like servrd. With this one, I think this is actually the boundary that's showing up. But that gives you a rough sense of it. You know, it's going to overlap right on there because the existing ground is right on there. And I don't think I can go turn triangles on from a reference. I can't change the feature definitions from the reference to show you what it would look like with the triangles on. What we're going to do is basically clip it to the existing ground to this. So you know the existing ground passes through here. Sometimes it's over here because those cut and fill volumes. You know, I just turned them off, but that gives you a sense of where that overlaps. If you have the existing ground, it's going to cover it up when you're trying to do visualization. So to visualize the finished product, what you want is existing ground only out here beyond the limits of this cut and fill, you know, beyond your daylight lines basically, and that's it. Okay, so since we're setting up for visualization and I have the level display on, I'm going to go ahead and turn off constructions because we don't want to see any of those extraneous lines. So we need to go to close out level display and reference display, and we're going to go over here to the terrain tab of the ribbon. We're going to go under additional methods, click the drop down there, and we're going to choose create clip terrain model. Now once this is located reference terrain models, so first we need to select this GDTMRD01. So select the boundary, and it wants clipping elements. So clipping element is going to be all our corridor handles. So I'm going to do this left, right, do this main line. Should be 3 there. I'll do the pond and US 98. And then reset when done. Now, the feature definition, if this isn't shown already, it needs to be set to DC drape. We're gonna be putting the aerials on there, so DC drape will allow us to do that. So change that before you accept everything, and we'll go through the offsets. And there we go. There's mostly there. It's mostly clipped. The only thing that's not clipped is right here around this intersection. So if we want to clip that, we can't really clip to another surface. It didn't really like that, probably because it's not flush with that other surface. What we can clip to though is we can clip using these boundaries. Again, it's not perfect either because they're not flush with it, but we had the boundaries that we created this other surface with. So if we add those, if I come up here to the feature management on the terrain, click the drop down and click add features, I can say locate terrain model. So that's the one I just clipped, the DC drape, and locate the element to add. So hover over this line and hit tab until you get the right element. So it's going to be the one from model detail 61 with the active profile, the fillet. That's it. Do the same thing for this line here. Hit tab until you get the pavement slope break from the MODLRD detail 61. Same thing, come over here, hit tab until you get the fillet with the active profile from the model detail model. And then this other piece here that wraps around, just hit tab until you find it. It's another pavement slope break. Now I can reset when done. Now the feature type on this, sometimes you got to play with what the feature type is. So for this one, let's try doing a hole, because really what we're trying to do is punch a hole out of the surface right there. So a hole should do it. So it definitely clipped it, but there's still a few pieces missing. So it's not ideal. Another thing we can do is we can change change it. See if that makes a difference. We could edit it manually. It's likely it's not going to change when you're at the point of visualization. You know, I could just go in here and delete these triangles in the middle. If you go under feature management there, so you have the option to change feature type. Oops, make my selection set first. 4 lines. Change feature type. So this time what I'm going to do is the drape void. So the drape options actually, the intent, the idea is that it drops it down to the level of that surface. So I've got these lines, I got these profiles, so we just need to lower them to cut right on that surface. And yes, we do want to create a void. So if I use the drape void, I can do data point to change for selected elements, and that cuts it out. So now if you look in your 3D view, yeah, there's a couple glitches there, but we're not going to worry about that. Okay, this is just for visualization purposes. So that's something you could go in and edit triangles on just to get rid of the extra pieces. If you're trying to get it to look perfect, it really depends how good you want it to look. So we got those triangles. So let me turn these levels back on. Turn this 98 and 61 back on. Better turn on the existing features too. So the next thing we need to do is drape the aerials in here. I turn on design, just kind of to get it back where it should be. And save settings. Okay, so we have all the triangles clipped. We need to attach the existing ground. This is important here. Switch the 3D view to active. So we're going to be draping in the 3D. So this is a 3D task. A lot of visualization. And you got to be cognizant of being in a 3D view for most of these tools. But so make the 3D view active, because you'll have a different option. You won't see the option to drape without that being active. And I come over here to my attach tools, where I normally go to attach references. If I click the drop down on that, I go to the second option, that's raster manager. And we are going to attach the SID files. So I'm just going to go here, file, attach, raster. And I'm going to, so this should be, if you go into your roadway folder, and you maybe in your project folder, go down to roadway and look for aerials and then SID. Control click, or well, click on the first one and control click and click on the next two files, end with .sid. Sort them by type if that's easier. Then you can hold down shift and select them because they're all in order. These default options should be okay. The open settings dialog, make sure that's checked, and then click open. So then this will come up, these attachment options, and this is the important option here, draping. Remember I said if this doesn't show up, you probably haven't made the 3D view active. So make if you made the 3D view active before you did this, this should show up, and you change the draping to yes. Because we set that feature definition to DC drape, it's going to show up on top of that existing ground. So I'm going to say yes, and I'm going to click attach. And you can change things like levels here as well. You know, I don't want this on a, say I don't want this on a construction lines level. It should be a DTM something or other. It should be well, just put on DTM triangles. It's going to the default level, whatever you selected currently. So right currently it's construction lines. So it brings that in. It should bring it in both views. Yeah, it's just taking a second longer than this 3D. So it's got to load up all the aerials now, but So we see the aerials in the 2D. Those are just 2D aerials, but in your 3D view, these are draped on top of the existing ground. So notice wherever the existing ground doesn't go, there's a hole here. There's no aerials there. If I rotate this, the aerial, as you can see, it's attached to the triangle, so it rotates with it. So it's a little prettier than that ugly green. So it kind of gives you a sense of kind of your existing features. And this is on, the view setting is on a pretty basic. Now if you go to one of the fancier ones, I think one of the smooth view settings, it may give you a little bit more detail. Some of it's going to depend on your graphics card and everything. And the main problem I have is it's a little bit dark with the shadows on there. Which is why the ignore lighting kind of looks a little bit brighter. But you can certainly play with the options and see what it looks here. But if you really want it to look good, you export to LumenRT, which we'll do in a minute. So don't worry too much about it looking perfect at this point. I think this was on ignore lighting. So that's the next exercise, 7.2. We're going to create a 3D drive-through animation before we do the LumenRT export. Because LumenRT, we're going to get out of this program. So right now we're still in this program. So here's how you would drive through on this one. We're going to go over to, so we're still in the master model file. Make sure your 3D view is active. I'm going to go ahead and close the 2D view. Make this bigger. I'm going to turn off a couple levels here. Construction lines and excess miscellaneous if needed. Now I've pretty much already cleaned this up, so all my construction lines are off. So I'll just leave that alone. So we're going to go over here to the corridors tab of the ribbon. And over here on the right, the 3D drive-through is where we're going to select. Next to the last button here. It asks me to locate a 3D view. Well, that's the only one I've got open. It asked me to locate the center line of the road. Now this could be problematic because I don't see the center line. I think maybe it was detached, or the display was turned off rather. So I do need the display of the alignment turned on. So it's kind of started over to commands. Let me try again. Click on this view. Select the center line of the road. So there we go, and it drops it to kind of be perpendicular with the center line. It's more like a cross-section view now. And we can tweak the angles a little bit. So what we're going to do is go over here to camera/target controls. We're going to give it a vertical offset of 12 feet. I mean, you could say, oh, well, driver height is lower than that. You can give it offset or whatever you want. Whatever looks good, really. And you can change the target control. So this is kind of how low you're looking. So if you want to look more straight on, I can say 2.5 feet instead of 1.5 feet. I can change the distance from 50 to 100. So it kind of basically zooms in a little bit closer if you increase that number. And that can work. I mean, you play with this some more. See, vertical offset of 12. This is more like a drone's eye view, or maybe a really high truck. So we do somewhere in the middle. And we go back over here to general controls, and here's kind of our play button. So we're just going to click play, and then driving through the corridor, and it's following the center line. That's all it's doing here. So again, the performance of this is going to start to be dependent on your graphics card. So I can hear the fan on my computer roaring right now. It's really trying to crank up. So now I'm off the proposed area. I'm just finished, so I'll go ahead and pause it. You can even change the speeds here or step manually if you want. So there's a few options there to play with. It's a handy tool, I guess. So now let's export to LumenRT. I'm going to change this back to an isometric view, first of all. And I'm going to change the active workflow. So this is only going to show up if you have your 3D model as active, which we do. That's the only one we've got open right now. So make sure your 3D model is active, and then come over here to workflow, and you'll see the option for visualization. You won't see this in a 2D view, but you will see it in a 3D view. So switch to visualization. And let's see here. You can further clean it up. It says, well, you could turn off the existing ground line if you want. So I got my server-RD. I got my GDTM. I'm going to turn that display off, because that I probably don't need. That's going to try to show the existing ground. I don't want to do that. So if I turn off the existing ground line in this file, it would be the DTM EP. I can even turn off DTM triangles, DTM vertices. All I need is DTM triangles EP and a DTM underscore EX to be able to show that. So that just may help a little bit. I'll turn off the contours. There shouldn't be anything there, but I'll turn them on off anyway, just to be on the safe side. I'm just going to go to the home tab here, and I'm going to go all the way to the right and just use the LumenRT button. And it just says animate in LumenRT. So it's going to process. It'll take probably a little bit. I would not try to do this on a low-end machine. If you're on a laptop or something that doesn't have a dedicated graphics card, just don't even bother doing this, because it'll probably crash. It probably won't work, and you'll be wondering what happened. Well, it's probably your machine can't handle it. So we got a decent graphics card on the machine I'm running this on, so even with that, it's taking a little bit to run, as you can see. So it'll open up LumenRT, and then LumenRT will go through the progress, and it's doing some more processing there. Alright, so there we have it, and so far it looks better. So I think turning off those levels probably helped make sure it knew what to do. So now we can see our proposed model on top of things here, and there's a little bit of there's obviously some issues. This is what the reviews are good for, and say, hey, you know, there's a traffic separator in there that we missed. Apparently we're milling and resurfacing over top of the traffic separator, and it doesn't look right. Really needs is probably some pavement brake lines in there to clean that up better. So if I just use the scroll wheel, I can kind of fly down this roadway. Best way to look at this is in VR, but unfortunately I can't show that to you on the video. So we'll do what we can here. I don't know why there's a little bit of a graphical glitch here. It didn't. So the curb's in yellow. It should have the materials. I don't know why it doesn't there for some reason. You got some issues. These are extra triangles on the existing ground line. Basically vertical lines. But as far as the model that we created, it's pretty good. Like I said, you clean up those triangles, you probably have to just go in there and delete them. So you can fly through just using the scroll wheel and then kind of dragging up here. There's a hole that needed to get fixed. In fact, I thought we had fixed it, but maybe not. So we just need some key stations in there. It's a good thing. This is why this is good review in here. Obviously, you know, this isn't done over here in the end. If you zoom underneath, you can see things too. In fact, if you go to your, there's my pavement base. Actually, that's not even the base. That's the existing ground sort of thing. If you go to your underneath it, you should see if you have your drainage utilities turned on. If they're in 3D, you should see them. I think we probably had them turned off. But if you have them turned on, they should get exported. Whatever's in 3D, whatever's turned on, should be getting exported. So you got 3D existing features, any of that should get exported as well. So anyway, just all you need to do if you have the Oculus Rift is you just kind of have this plugged in, and you'll be able to pop it on and control and navigate in there. And I think that wraps it up. There's other things you can do with this tool. I'm not going to get into that, but you can create movies on here. You can add trees and people and animations and fun stuff. Thank you for joining me today for the CAD Office series for F.Connect. This was Chapter 6, Earthwork, and Chapter 7, Visualization for the F.Connect Roadway Design 3D Modeling Guide.